Welcome to the third part of our Alibre Atom 3D introductory series of videos. So in the previous two parts we created an M8 socket cap screw and an M8 hex nut. So now we could use the assembly workspace to combine the two components together. So to do that we just need to click on this blue and yellow symbol, and that will open up the Alibre Atom 3D assembly mode. The first thing that happens when you go to assembly is that you get an insert part subassembly dialog. So this is just the software asking us, right, what's the first component we want to include in the assembly? And it will default to the last folder where you saved your parts. So it should open up the location where you saved parts from the previous two. If not, just browse to it in your through your file browser. So in this case, I'm just going to select the M8x30 socket cap screw and go open. And then I'm going to left click once to place one into the assembly. Now if I wanted multiple copies I could click more than once, but you just want the one, so now I can click finish. I'm now just going to rotate the view to a 3D perspective so I can see a bit more clearly. And so now we have our first part in the assembly. So there's a couple of things very important to remember with assemblies is you need to fix the first component you bring in, and then you can align other components to it. Now, a mistake I've sort of seen people who are new to assemblies is that they bring the first part in, bring another bit in, and align the two together. But without fixing the first part, you can end up with things moving unexpectedly, or not being positioned how you would expect. So there's a couple of ways we can go around this. There is sort of a shortcut. So if I select this part here, we can click on anchor part, this button here, and that will just fix that in position so it doesn't move, and then you've got a stable piece to align other parts to. There's quite a few sort of tutorial videos on various or similar parametric CAD systems that recommend just fixing the first part. I would personally recommend against doing that, just on the point of view that that part isn't in any particular position in relation to the world coordinates for the assembly. So Alibre gives us an origin and a set of reference planes for the assembly workspace itself. That part was just dropped in wherever I happened to click, and I don't know that exact position. So rather than anchor it, I'm just going to select and click on anchor again to turn that off. I would recommend using the constraint tools to position this first component in relation to the green assembly references. So then it's in a known defined position rather than just fixing it wherever it happened to come in. So to do that, I'm going to go to constraint, click on the constraint tool, and that brings up this assembly constraints dialog. And the first constraint I'm going to apply is I'm going to pick the cylindrical face on the outside of the cap screw, which would be the threaded area, and then I'm going to pick the x-axis from the assembly. Now I can either pick this by selecting it in view, or I can select it in the tree. So I'm just going to click on the x-axis, and with those two selected, Alibre Atom 3D has chosen. It'll automatically select what it thinks is the most sensible constraint for what's been selected. So in this case, it's gone coaxial. We don't want an offset, so that looks good, so I'm going to hit apply, and that's now added the coaxial constraint into the tree. The tool stays open so we can continue adding constraints. So the next constraint I'm going to add is I'm going to pick the flat face on the underside of the head of the bolt, and then I'm going to pick this YZ plane that's sort of parallel to the face we've just selected. And that's going to default to a coincidence, so that just lines the two things we selected up. I'm happy with that, so I then click apply. And the final constraint we need, if I just left click and drag on the part, you can see that the only way it will now move is it will pivot. So we've lined up the axis, we've positioned the bolt head, but we haven't controlled that rotation. So to do that, I'm just going to pick one of the flat faces on the inside of the hex socket, and then I want to pick a plane that's sort of predominantly perpendicular to it. So in this case I could use the XY plane. Now that will jump to a coincidence because we've selected two planes, as that was the last option we used for that type of selection. And you can see that the constraints in the tree turn red. So the reason that is that because of the other constraints we've already created, it can't satisfy that requirement. That's not a problem. All you need to do is, don't worry when these turn red. The constraint isn't finished unless we hit apply. So I can change the type, and the option on the end here is angle. So I'm going to click on that, and then I'm going to set that to 90 degrees, and then just click into a box in here. It will then prompt the software to update. You can see the result of the change, and you'll notice now all the constraints in the tree have gone back to normal, and that's fine. So I hit apply, and at that stage I can now hit close to close the assembly constraints dialog. And now if I left click and drag on the part, it is now fully fixed. But now we have actually centered this. We've lined it up onto the x-axis with the head there lined up against the YZ plane. So this is now in a nice defined position. It's not just sort of arbitrarily sitting in a random position in 3D space. So now we've got our hex bolt in there. The next thing I'm going to do is I'm going to click on the Insert Design button here under the Insert New section of the menu, and I'm going to select the hex nut and then click Open. I'm going to left click to place one into the assembly and click Finish. And now we can line up the hex nut with the socket cap screw. So to do that, I'm going to go to my constraints, and the first thing I'm going to do is I'm going to select the cylindrical face on the inside of the nut and the cylindrical face on the outside of the socket cap screw. Now the last selection we used was constraint we created was an angle, so that's what Alibre's defaulted back to, but in this case we want coaxial. So I'm going to click to change that to coaxial, and you can see that the nut is then lined up onto the threaded section of the bolt, so that looks good. I'm going to hit apply. Now I'm going to put a constraint between the sort of opposing faces between the nut and the underside of the bolt head. Now it's defaulted to a coincident for those two. However, in this case we'd actually like to leave a bit of a gap, so I'm going to change the type to offset, and that just allows me to specify a distance between the two. And I'm going to make this 15 millimeters, so just type 15 into that box, and then if I click in the geometry box, that'll just update the position. That looks good, so I'm going to hit apply. And the final thing is, if I just left click and drag on this, again, like the socket cap screw, we still need an additional constraint just to control that rotation. So I'm going to pick the top face of the nut, I'll pick the XY plane and set that to an angle, and then I can set that to 90 degrees and hit apply. And then I click close. And now if I left click and drag on the nut, you'll see that that will no longer move. So that is two parts assembled together, and we can adjust positions of these by editing the constraints. So for example, if I wanted to move the nut closer to the underside of the head of the hex bolt, I can just right click on the offset, go edit, and let's say change that to 10, click in the box to see what happens, and then go OK. Or I might decide, okay, actually no, I did want it a 15 mil, in which case we can go back into edit, change the value again back to 15, and go OK. So basically, with the parts in an assembly, you can use these constraints to control the position between the parts, and adjust them, and any parts linked to them will move together. So you can sort of have whole mechanisms that will all move and interact as they would in real life. So with that done, I'm going to go File and Save, and this will default to the same folder where the parts were. So I'm just going to call this Nut and Bolt Assembly, and click Save. And then we can click the cross top right to close the assembly down and go back to the Alibre Atom 3D home window.